What's going on? How you all doing today? How did you all did yesterday? How did you all did tomorrow? So, subject. I am in the last. I am like it's like a metaphor. I mean, it's not like that doesn't exist, but I want to express something beyond. I am at the last level of physical science, electricity and electronics. PennFoster. All the formulas that I have been familiar with. Uh, permeability are materials that could be magnetic, that are magnetic. Yeah, that could be magnetic. So we are dealing right now with current, resistance, and volts. Column laws and formula for electrical power, parallel circuit, the resistance in it, conversion for energy, for electrical energy. We did that like at lesson one. At lesson one, we did all of that. So meaning it's everything comes back always. So whenever we're doing a new lesson, whatever was in the first lessons, they hit us back in the fifth lesson or in the sixth, last lesson. So now here we have the one watt hour equals 3,600 joules. 1 BTU equals 1055 joules. 1 calorie equals 4.1868 joules. That is in the 10th thousandth joules. 1 kilowatt equals 1,000 watts of hour. 1 joule equals 0.00098 million BTUs. No, 100,000 thousands. Yeah, 100,000 BTU. And then we have the 1 joule, which equals 0.239. You guys already know. So I went ahead and just did my own journey today at Walmart, and I went ahead and got me a one a digital multimeter. Voila! Digital multimeter, meaning we're checking batteries, we're checking outlets, we're checking transform what you call this thing again? Anything that has to do with electricity that this device can take the watts of it. We are taking measurements of everything. So meaning this right here is good for that. And whether you want to check watts, 300 watts. That way, I believe 300 watts, 300 volts is for when we're checking the battery, see how much volts it has. So if the battery is beyond 200 volts, you might want to put 300 volts. So that way you can see the amount of the whole volts before 300, which is an increase in amount beyond the battery that we're checking. Then we have omegas, then we have kilo hours, then we have amperes, then we have everything is here, man. Everything is here. See, so it's a wonderful device. Right now I am opening it because I need supposedly to place a battery in it. Yeah. So I managed to get it open. It is the same as a motherboard of a computer, chipped out and everything. So the battery seems to go here, right here in this little spot. See? And we get to put it right there and then close it back. But then on top of that, let's put this to the side real quick. It came with 2 strips. The red strip, which is the positive strip. So remember, guys, red, with myself, red is positive. Because I am taking my PennFoster education learning to the physics where I need to study it. It's a real educational system. So I really want to learn all these things, and we should all really worry sometimes. And then comes with a dark Negro colored strip, which is negative. So negative is dark, which is Negro, black, and then red is positive. So whenever checking the electrical batteries or everything, we always have to place it where they belong, or else not sure. Never tried it before, but they say I've seen humans playing with cars and they do stupid things and poof, and the battery just bursts out. So there's things that I have to practice in this small battery right here. See, the same small battery that it brought, we can always use like small battery, AAA, AA, and a 9-volt battery right here, heavy duty. It's a company called Paco. Paco Power Resistance. So I also went ahead and got a battery checker, 12 volts. This right here is a battery checker. Now, sometimes we buy batteries. They're guaranteed for batteries to last a lifetime sometimes. But we can always check that battery when we buy it and see if we were scammed or not, or see how much life is left within our batteries of our vehicle, our whatever device we have, or whatever it is. So meaning, here I will be fulfilling this right here. This untangling all this, and I went ahead and bought my own thing. So we are really learning. PennFoster is interested in. This is where I get to check this battery right here. So this battery is brand new. There's the homemade battery Paco, which I won't even throw this battery in the floor or blame it for whatever it is. But some batteries aren't as pure as some brands. Like sometimes you would say Duracell would be so bad. Duracell is so good because Duracell was promoted. But then you go to Energizer. Energizer for me is better than Duracell, but I like Duracell. Get it? Duracell has some devices like solar panels, things like that really matter. So when you go to Energizer, sometimes in Energizer you will find something that you don't like. Sometimes in Duracell you will find things that you don't like. So not everything is purchasable. Get it? So this right here is the positive clip with a strip and a negative strip with a clip, which we put on top of the battery, and the battery checker will tell us if the battery is empty, low, 50%, or full. So then we have charger and alternative charging. So this is a charger alternative in the battery condition. So the charger alternative, I believe, is mostly checking how it's charging. If it's receiving chargement and things like that. Get it? So what we're gonna do right now is get straight to the deal. Before I place this battery of Paco within my digital multimeter, which is called a thermocouple or couple thermal. I would want to check this battery and see if the battery is good enough for my digital multimeter. Yeah. So let's go ahead and try it out with the battery checker and see how things really go, because this turns on according to the battery charging. So it tells us what's the charge and what's the things in it. Get it? So let's go and check it out. So I'm going to set this right here and put it right here and seek for the positive side of the battery. This is the negative. The negative. And then this right here is the positive. So according to our battery checker, the Paco battery that came fresh from the box is not guaranteed to resist long and have full resistance. It is at low, 50%, then high. So the battery is at low, 11.5 volts. So that is the Paco battery. So there we go. Everything over here is done well. So I am not, we shouldn't expect that this battery from Paco really lasts long. So it's not something that's going to last very long or anything that's going to be rewarded long life, but it comes free with the package for us to try out, isn't it? So let me go ahead and find a different battery. So we're going to have phones to check. I have an iPhone 4S. We're going to have phones to check and things like that to check the batteries and all that. BlackBerry right here. BlackBerry. We're going to check all of these phones and get to the solution. So we are going to be inserting the battery now inside the digital multimeter. So according to me, black is negative. Okay. So it is inserted already. See? Inserted. So we're going to close this right here. And try to close this back and see the results. It turns on perfectly fine, see? But this wasn't the one that I really wanted. I wanted the one with the 0.000, which is thousandth. Okay. So let's close this right here. It's sad because I have to use a scissor. I was just thinking about buying. I'm like, this object might just, this device might just be so easy to handle, but we would actually have to really use things to really open this. And I also was going to buy a solder and a heat welder to remove an electrical welder to remove chips from computer with flux and glue removal. And then get the cleaning to clean the surface where the chip goes, and then glue to stick it back. And how they play with computers, learn how to fix computers. Keep going there, keep taking certificates and things like that. So let's first read the digital multimeter manual, user's manual. So this product is made in the USA. Page 1 says, due warning, to avoid possible and electrical shock or personal injury, follow these guidelines. Let's follow these guidelines. Meaning, do not use the meter if it is damaged. Before you use the meter, inspect the case. Pay particular attention to the insulation surrounding the connectors. Inspect the test lead for damaged insulation or exposed metal. Check the test leads for continuity. Replace damaged test leads before you use the meter. So we need to inspect the test leads of damaged insulation or exposed metal. Battery checker. Before we do anything. So, do not operate the meter around the explosive gas, vapor, or dust. So we cannot use the meter around explosive gas, vapor, or dust. Okay? So everything has to be nice all around. Do not apply more than the rated voltage. So if we go for 300 volts, make sure that we stay with a battery that has 250 volts. Get it? We don't want to go 300 fully. So when measuring current, turn off circuit power before connecting the meter in the circuit. So everything has to be turned off. The battery, everything turned off to measure the current. Get that? That way we don't cause anything. When servicing the meter, use only specific replacement parts. Use caution when working with voltage above 30 volts, AC RMS, 42 volts peak, or 60 volts DC. Such voltage possess a shock hazard. When using the probes, keep our fingers behind the finger guards on the probes. Behind the finger guards, the circle right here, of the probes. You never go to the front, back. When using, okay, so when making connection, connect the common test leads before you connect the live test leads. When you disconnect test leads, disconnect the live test leads. So meaning we shouldn't have, there's different ways to check current, resistance, and volts. Resistance, we have to turn off the device. Current, I believe we're supposed to keep the device. Yeah. Wave, current. And then volts is how much volts does it have. Get it? Charges. So electrical symbols. Alternating current, direct current, both direct and alternating current. Caution, risk of danger, refer to operating manual before use. Caution, risk of electric shock. Earth, ground terminal. So earth, ground terminal. Where is the earth, ground terminal? So I believe when we're somewhere measuring, it will tell us where we are. So it would sense itself that we are in earth ground. Fuse, meaning it tells us that we're going to be careful with the fuse. It could happen, a fuse could happen, like we're in a fuse. Conforms to European Union directives. So I don't believe this from the USA, United States, but wait a minute. So this comes from Arizona, but made in China. But they said conforms to Europe's union directives. Now the next sign is the equipment is protected throughout by double insulating, a reinforced insulation. So that meaning we even need gloves for this. Okay? If we're not too careful. So here on this page is going to tell us what these all are. With the spinning compass type device where he's the scale where we pick things, and then the digital LED screen. So now, number one is the display screen. 3.5 inches of digital LCD with a max reading of 1,999 volts or numeration. It doesn't reach 2,000 volts. So, function range switch right here. Number two, function range switch used to select the desired function and range, as well as to turn on or off the meter to preserve battery life. Set the function range switch to the off position when the meter is not in use. Number three is the COM terminal, which is right here. The Negro one, the black one, the dark one. COM, see? COM. This terminal is a plug-in connector for the black LED for all measurements except temperature measurements. This is the temperature measurement. Oh no, it's except temperature measurements. So we can't, it works for all measurements, but no temperature measurements. Number four is the red one. Right there, the red one. As we all see, the red one is in the middle. As the COM works for everything besides measuring temperature. Right here is the VMA Omega terminal. This terminal is a plug-in connector for the red tester, lead for voltage, resistance, dial D, DC current, 200 mA, and battery measurements, 10A terminal. The number 5 is the blue one. 10A, 10 amperes terminal. Plug in connector for the red test lead for current 200 mA to 10A measurements. So there we just saw the function range switch, display screen, COM, terminal, and the 10A terminal. So it does what it do, and it's really here. So low battery indicates shown as a display. I do apologize for that right there, but I something felt like it just flew through me, so I wanted that. But storage environment. So everything in here is measured. See? DC voltage, AC voltage, current range, overlid protection, and many more. So we are going to check the phone battery. So measuring DC volt, connect the black test lead. The black test lead to the COM. So here we got the black stripe, the Negro color. We're supposed to remove this cap right here. You don't want to lose it because you want to put it back cover. You don't have your devices all thrown around. That's how we do not want to have our devices all thrown around. So let's go ahead. The device is off. We are going to set it right here. And this is how to measure DC volts. So connect terminal and chain and the red to the VMA omega terminal. So now we got the red one here. And we're going to measure it well. Let's remember, way the user's manual expressed it to us, we're supposed to keep our fingers behind this circle right here. That circle guard. Never go beyond it. Always like that. So we take this right here, remove it, keep it right there because we do not want to lose our devices. We want to keep our device nice and good because this is for our educational purpose. Even if you graduate, take care of these devices. One day you'll have a home. And we would want to do things. Get it? So set the function range. Step 2. Set the function range switch to desired voltage. So desired voltage, remember, but I thought to myself, always go higher. 300 voltage. 300 voltage. Now we have 300 voltage. 300 voltage, and technically use the magnitude of the voltage So let's get straight to this. 3, connect the test lead across the source of circuit to be tested. So I am going to need a battery right now. I'm going to turn this off real quick and get me a small battery and test the voltage on a battery. So I am going to use my screen, my movie projector's battery to check the voltage within the battery. So according to the steps, you have to put everything in a good surface. I need to get me a welding surface or something like that. So 3, connect the test across the circuit. Read the reading. Okay, so now we're going to set it on. See guys? On 300 watts. Battery. Negative and positive. So this one has 0.01 volts. This AAA battery. I am now about to place it somewhere where we can actually see the numbers and confirm it to ourselves that me, Exio Elio Cabreja, has just checked his first volts in life. Because I used to watch these devices when I was young and be confused about it. So positive, positive, and negative. So let's go. Notice how a 1 appeared there. See, a 1. A 1. Now let's do it again. One, one, one. So that is 1. So that right there came back as 1. So we're going to write this down and say that the Energizer Max AAA battery with how many watts to say? Has 0.01 voltage. Okay? So now we got voltage. So now we know how to check voltage. Here is a battery which has positive and negative from a phone. Remember, positive is red, negative is Negro, black. So now we are going to check negative and positive. So keep our fingers always in the back. Okay, so this battery seems to be completely dead. No responding. Yeah. We're going to need a battery that we use the most. So let's check the BlackBerry right here. As you'll see, the BlackBerry is a great phone, magnificent, marvelous. It's a beautiful phone. So, meaning, let's check and see what results we can get from a BlackBerry battery. So negative, positive. Let's go. So I think we would have to charge these to find the voltage in this. So we're gonna cut that experiment right there and try with something else. But as you guys see, the BlackBerry is a beautiful phone. Look at it, still brand new, still nice. So I still like Blackberries. Blackberries are cool. Blackberries have good camera still. So people choose what they want in life. So let's check with the battery checker. The battery checker. Let's make sure that the battery checker tells us that the battery is good. How long could it last? So the battery checker. Hmm. Well, apparently this battery is not strong enough to ignite the voltage and be checked. So we already found out that the battery not worthy for our battery checker. So that's canceled. So now we want to check resistance. See what the manual have to tell us about the multimeter digital device. So we learn how to measure voltage through there. So I'm going to do a formula to find the whole resistance. Now we're going for the current, measuring current, the COM. So set it to 200, 200, turn it off, 200 MA. So connect the black test lead to the COM terminal. If the current to be measured is less than 200 MA, 200 MA, 200 MA. So MA, this is A volts, volts. We read earlier, volts right here. Alternative currents and then direct currents. And so switch to so set the range switch to desired volt. Desired volt current. So we're going to go to, this is the voltage. Now we're going to the other side. We went from voltage to, we're checking out alternative current. So alternative current, we could say 300. That is the voltage. Alternative current. Alternative current. So set the range position. If the magnitude of the voltage to be measured is not known before hand, set the range switch to the highest range. So right now we are doing the alternative. I put 300 volts. Now we are going to go ahead and test the AC voltage, alternative current, AC. Now remember, like we said, positive, red, negative, Negro, black, simple color, Negro, black. So let's go down to the multimeter, which I want you guys to witness the voltage used of the alternative current. So now the battery is faced towards us. Positive, negative. Now let's see what results we can get. Excuse me. I think we're going to have to do it the opposite way. It's the way it is. Red over here, Negro over here. So we have 0.000 of alternative current. So there is no current at all, as much we try within any of this. See, no charge, no anything. So the current is 0.00. Now, we're going to check the rest of it. Let's see how to find DC current, which is direct current. Direct current is with the COM. So 2A, 200 MA, 200 MA, 200 M, 200 M. So it would be 200 MA. So this time, we have to turn it back off and connect the red wire tester to the COM, to the 10A ampere. And now we can turn it back on to the 200 MAs. Now we're going to come down here. Let's check it. Positive, negative. Woo! That right there is working. Direct current. This battery does not play. I am hoping you guys are watching this and we're all learning and seeing things, because watch as we go to this energizer and check the direct current. 43.9. I'll say 43.9. 43.9. Direct current bless you. Bless you too. Thank you. Let's check it again. I do apologize for that. 45, 49. No. 42.8. 42.8. 42.8. That is direct current. Ladies and gentlemen, these batteries are really strong, meaning they have a good current. So now let's go straight to what's next. Now we got direct current. We are going to, yeah, I was right, eight something. Get it? Down there. Now we're going to measure resistance. Connect the black Negro test lead to the COM terminal and the red test lead to the VMA Omega terminal. So now we're going back to the red circle, red outlet with the red tester. You guys already know. It's already plugged there. Now what's the next step? The next step will be set the range switch to the desired range, Omega range. Now, where is the Omega range? The Omega range is right here. So we're gonna say we don't have 2 million to check. 2 million of resistance. We don't have 200K. We don't have 20K. We don't have 2K. But the most we can try is 200. 200, and it seems like we get a O to start, to initiate. Then it will say connect the test lead across the object tested. Read the display. So now we're going back down here again with the film, and we're going to find out how much resistance does this battery energizer AAA has. So now we are here again. Oh, negative on this side, positive on that side. Now we have to read, once we connect this, and here we go, what the digital multimeter, which is a thermocouple, has to read. Nigga. La corriente. No sé. So, right here it says 0, no resistance. No resistance at all. So these batteries are kind of cheap, but they're good. Yeah. I don't go too much for brands, but I'd say brands are good. But there is no resistance. It's not much we can do. Positive, negative, touch, no reading. So there's 0, no resistance. So resistance, eso es esto, el botón que doy vuelta para medir. 0.00 resistance. So now, DOD test. Connect the black lead to the COM terminal. DOD. Let's remember we have current voltage to find resistance. So DOD. So the DOD test. It says, no, the polarity of the red lead is positive. Set the range switch to position. Connect the red test lead to the anode and the DOD to be tested. So I don't have the. This is all here. This is all here. That's just what we're doing. It says you're going to see OL. We're going to see OL. Then OL, we're going to place the positive here, the negative here, and there is no charge. So it's 0. We'll show display. Connect the black lead to the COM. So set the range switch to the positive. So just connect the red to the positive. Connect the black test lead to the COM terminal and the red to the VMA omega terminal. The polarity of the red lead is positive. Set the range to the positive position. We are already there. The display shows the approximate forward voltage drop of the diode. If the connection is reversed, OL will be shown on display. So the connection is reversed. OL is on display. So if we come down to the screen, positive, 0 OL. So OL OL is like that. OL. We do things like that, and OL. So you guys already know 0. So the dial D is OL in reverse. So meaning in reverse. We're going to go to another area because I have other things over here doing. People are talking over here, and I'm trying to do my project. So let's go. Excuse me. So we're gonna do a test over here. Basically, my siblings have guests and they're talking. So can't be over there. So the Energizer Max AAA, not worthy for battery checker. Not worthy. So it cannot be battery checked. It has 0.01 voltage, 0.00 alternative current, 42.8 direct current, 0.00 resistance. And then in reverse OL, meaning the DOD battery test. Now we're going for the battery test. This one right here might show success, meaning it might have a progress. Get it? So this one right here is we're supposed to come, everything plays nice. Step 1, step 2, go to the battery section. Bat. battery. So we're going to go to 9 volts to 1.5 volts, or to, yeah, I would say 9 volts. 9 volts. See? So we're going to check the battery right now for the battery test. Is it still functioning well? So we're going to connect the positive to the positive, as remember. Red is positive. Black Negro is negative. Yes, we have results. Results are in. 147. 147. 147. 147. I left the pen over there. 147. 147. So 1.47. So this is not a rechargeable battery. These are recyclable batteries. It becomes recycled energy. Yeah. My studies, it doesn't have resistance. It doesn't have alternative current. It does not have diode. Yeah. So technically, if we speak and do it again, we can see the results. One 47. Okay. 147 volts. I'm going to turn that off, and we're going to see if we can start our own formula to solve the battery. So we have battery test volts, we have direct current, we have resistance 0. So according to us, we're looking for resistance. Let me check something real quick in my digital data. So in resistance, R equals resistance and V equals voltage. I equals current. So we're going to solve this one right here, and we're going to say we're going to find the resistance because we have the direct current, and then we have the voltage. So resistance equals V divided by I. So R equals 0.01 divided by No, it should be on the other one. Yeah. Divided by 42.8. So we're going to use our calculator here. So resistance is very poor in this battery. Resistance is not rewarded. So 0.01 divided by 42.8 equals resistance is 0.002336444859813. So like Energizer says in the commercial, the resistance of this battery comes from space, man. From space. We're not even lying, from space. So this is beyond the tens, no ones, oneth, tenth, hundredth. So from the thousands, it's when it starts to ignite the resistance. So now we got resistance. We already got voltage. So we already got voltage. We have to solve for voltage. Now current, we got current. So voltage and resistance. So voltage, we have 0.01. Then we have resistance, which is 0.00. So if we was to do that, so we can only solve for resistance here. We can't solve for nothing else. We can't do volts. Volts is already solved. Current is already solved. Direct current is 42 point. Okay, so the alternative current must be if it's voltage divided by resistance, which is 0. The alternative is current is 0.01 or 0. So we say 0.01 divided by 0.00 equals 0, all zeros. So everybody gets 0. So current is 0. The alternative current is 0. The direct current is 42. Resistance is 0.000233644859813. So yeah, this battery is low-key great. Does well. This battery does well. This battery doesn't show so much resistance, but it has, and I apologize for yawning, resistance. So now that I have this physically with me and physically understanding that I have all this with me, and technically I just purchased these things to study and do my thing. Basically, yeah. So the Energizer Max in this experiment it is not worthy for a battery check with a battery checker. It has 0.01 voltage, 0.00 alternative current, 42.8 direct current, 0.000233644 0.4859813 resistance. But we're taking it as 0.00 because that was the measurement. But when we did the formula to find the resistance, we actually got the some numbers at the end at the calculator. Get it? So the DOD is in reverse, OL, and the battery test, which is the voltage, the I think the actual voltage it went on is 1.47 voltage. So you guys already know, and yeah, everything is good. So you already know, man. Out here doing my thing, out here really, really learning new things and testing new things. Next thing you might see me welding a part of a computer and having like a LED telescope where I try to remove a chip from a motherboard and place it where the new one where it goes, or replace the core where the processor goes and things like that. But yeah, this battery is worthy. This battery, don't expect it to be so out there that is the best, but it is one of the finest batteries we can ever use or purchase. So you guys already know, man. It's me, Exio Elio Cabreja, with a new video, new post, a new video, a new film. Electricity and electronics. My last lesson within the PennFoster educational system, graduating in a few days. Well, you guys already know, like I said, I'm going to start going to the YMCA. You know we gotta go to YMCA because I want to swim so I can lose my weight perfectly and do things. Ready? So you guys already know. Take it easy and make sure to stay tuned for more.